Hi, welcome to a conversation I once had with a kid on a plane. So, once many years ago, I was sitting on a plane and there was a kid, really a young teenager, sitting next to me. He turned to me and said something like, "I don't believe that cell phones are actually dangerous to planes. I once turned on my phone on a plane and we were fine." So this video is about statistical mistakes we might make in everyday life, especially when drawing conclusions from anecdotal data. My response to him went something like the following argument. Imagine a situation where, if one person turns on a phone on a plane, there is a 99% chance that it won't cause any problem. But there's a 1% chance that it will crash the plane. Turning on a phone on a plane is probably not that uncommon. So let's say that most planes have around one person on them turn on a phone. There are about 30,000 commercial flights in the US per day. So in this scenario, there would be a couple hundred plane crashes per day. And yet, if we test the safety of cell phones on planes by turning on one phone on one flight, there's a 99% chance that we'll be fine and conclude that it was safe. He asked if I had been on the debate team in high school. Okay, so this video isn't going to be about the safety of cell phones on airplanes. Instead, it's about how we can easily make statistical mistakes in everyday situations, especially when we draw conclusions from anecdotal data with small sample sizes. So I should point out that there was nothing unusual about this kid's logic. We do things like this all of the time. So often, if we're trying to figure out what to do in some life situation, we'll ask people around us for advice. So let's say a friend says to us, "Yeah, when I was in that situation, here's what I did." And then they describe some course of action, and then say, "And it worked out fine for me." If we decide to take our friend's advice, it's probably because we decided that their experience implied that that course of action was okay. We usually don't try to assign a rigorous probability to the success of taking that course of action ourselves. Or let's take another example. Let's say you have some old-ish food in your fridge that you're not sure if you should eat. Perhaps you say to yourself, "I made this once before and ate it when it was about this old. I was fine." But would you eat that food if the chance of illness was 10%? Your one-time experience with this situation in the past doesn't rule out that scenario. Here, we'll look at some of the mistakes we make when we draw conclusions from anecdotal information. Note that none of the numbers in this video are meant to accurately reflect reality. They're just to demonstrate how we can make mistakes. Okay, let's get started. When we use anecdotal information, it's not unlikely that we base our conclusions on data with a very small sample size. As we've seen, even a sample size of 1. So let's look at the example of testing cell phone safety on a plane by turning on a single phone on a single flight. When we do a test like this, we're really not modeling the relation between a phone and a plane as probabilistic at all. Instead, we're acting like there are only two possible options. Either the phone has no possible effect on the plane at all, or turning on the phone will certainly crash the plane. These aren't realistic models. Now, even with a sample size of 1, we do learn something. Successfully arriving at our destination after a phone has been turned on en route does rule out the hypothesis that turning on a phone will certainly crash the plane. But we can even say a bit more than this. If we turn on a single phone on a single plane and the flight goes as planned, we learn that with a phone being on, the probability of the plane landing safely is probably not very small. In other words, if we turn on a phone, the probability of the flight landing safely may be 90% or 99.9% or 99.99999%, but it's almost certainly not something like 0.1%. So the test does contain some information, but it doesn't really differentiate between the following 3 hypotheses. Hypothesis 1, the probability given a single cell phone being turned on of the plane crashing is 10%. 2, the probability given a single cell phone being turned on of the plane crashing is 0.1%. And 3, the probability given a single cell phone being turned on of the plane crashing is 0.00001%. Strangely, in our minds, we might translate any of these hypotheses as, it'll probably be fine. But these are very different hypotheses, which becomes clear when we consider a large number of flights. We can reasonably assume that a person turning on or leaving on a phone in a plane is not a rare occurrence. Yet, plane crashes are a rare occurrence. When we consider the number of flights that occur in a day, or a year, or a decade, we know that the probability of a plane crashing due to a single phone being left on must be extremely small. And this also tells us that we learn basically nothing compared to what we already know by turning on a phone on a plane and seeing what happens. We reiterate, though, that it's not wrong to use small samples to draw conclusions. Even a sample of 1 contains some information. What is important is to not attach more significance to the result than is actually justified. Another thing we can see from the cell phone example is that risks that might be considered acceptable on an individual basis may be completely unacceptable for a large population. We can imagine a hypothetical and unrealistic scenario where the probability of a single cell phone being turned on causing a plane crash is 1 in 100,000. A lot of people would not consider this to be a serious risk if they were planning to take a single flight. But in a country that has around 30,000 commercial flights per day, this would be a completely unacceptable level of risk. Let's look at a couple more hypothetical examples. Let's say a car company realizes that there is a safety flaw in one of their vehicle models. The issue is expected to cause a serious safety hazard in 1 out of every 10,000 vehicles. An individual consumer may not find this too concerning. However, if the company sells several million of these vehicles, the overall risk is substantial. Similarly, Perhaps the probability of a certain severe natural disaster in a certain location is estimated to be 1 in 100,000. On an individual basis, this risk is fairly small, but it is important if, say, this is the location of a city of 10 million people. So, even if a risk is evaluated properly and considered acceptable for an individual, we should not make the mistake of assuming that the same risk should be acceptable for a populace. So, risks that an individual might consider safe may be evaluated differently by a company or by governmental entities. Lastly, we'll briefly mention one more complication that can arise easily in anecdotal information, and that's survivorship bias. Survivorship bias occurs when your probability of hearing about some experiment depends on the outcome of that experiment. For example, let's say a bunch of people try a fad diet that doesn't work. However, although the diet doesn't work, some people who try the diet lose weight and some gain weight just through normal fluctuations. What happens if, for example, people who lose weight attribute it to the diet and tend to enthusiastically publicize their results, but people who gain weight tend to not report their results? So not only may your data have small statistics, but the data may be skewed as well. It would be easy to get an incorrect impression that the diet works, even when it doesn't. Now, survivorship bias isn't limited to cases where one is using anecdotal information, but when gleaning information from anecdotal sources, it's difficult to control for survivorship bias. For more information, you can check out the video, The Look Elsewhere Effect and Survivorship Bias. Should you trust this business's stock tips? Okay, let's summarize. In this video, we've looked at some statistical mistakes that can happen in everyday life, especially when we draw conclusions from anecdotal data. We looked at the dangers of drawing conclusions from statistically small samples. We also saw that conclusions about what is considered acceptable risk on an individual level should not necessarily be applied to large groups of people. And finally, we also saw how survivorship bias can creep into anecdotal data.